Hello students, now I am going to discuss the new topic, that is the thermal expansion. I have discussed earlier that what is thermal expansion? The change in size of the body due to heat is due to heating is called thermal expansion. Okay, so thermal expansion thermal expansion means what? Thermal expansion means after heating, when any substance expand, then means any substance expand or contract, then this is called as what? Thermal expansion. Okay, so it has been experimentally observed that when a substance is heated, it expands, and when it is cooled, it contracts. So we will now consider the thermal expansion in solid, liquid and gases separately, because thermal expansion occurs in solid also, liquid also and gases also. So first I will discuss the thermal expansion in solid. A solid has a definite shape and size, and when solid is heated, it expands in all direction. All direction means it expands in length, area and volume, all. Clear? When it is heated. So the increase in length of solid is called as what? Linear expansion. And increase in area is called as what? Superficial expansion. And the increase in volume is called as a cubical expansion. Clear? So once again, increase in length of solid due to heating is called as what? Linear expansion. Very good. And increase in area, superficial expansion, and increase in volume, cubical expansion. Okay, so now let's try to understand this through this activity, linear expansion of solid. So for this, take a piece of iron. Clear? Take a piece of iron wire, slip a curtain ring through the wire and stretch the wire between the two vertical stands. You can see here two vertical stands are here, and adjust the position of the stand in such a way that the wire is just tight. Okay, wire is what? Just tight. Then what happens? You can see this in figure A. Now you heat the wire. Okay, heat the wire over a flame. What will happen? What will you notice? You will notice that it has become what? Loose. You can see here it has become loose. Okay, so this indicate this, and this is indicated by the dangling ring. You have placed the ring here, so this is indicated by the dangling ring, and this shows that on heating, wire expand. Now remove the burner and allow the wire to cool. Okay, so again what will you notice? You will notice that on cooling, you will notice that on cooling the wire contracts and again becomes what? Tight. Okay, now different solids expand by different amount for same rise in temperature. Clear? Like brass expands 1.5 times more than iron, and this I have discussed in the previous video also, that change in temperature of the body depends on what? The quantity of heat imparted to the body, the material of the body and the mass of the body. Some substances such as invar, pyrex, glass, etc. expand negligibly on heating, and that is why pyrex glass where we use, yes, we use in chemistry lab or in physics lab also to make the glass apparatus. Why? Because they expand negligibly on heating. Okay, now I am going to discuss some applications in daily life. So first is the telephone and electric wires. When connected in summer between two poles, they are kept loose. Why they kept loose? And the answer you will write is what? So that they may not break when they contract in winter. Clear? They may not break when they contract in winter. On the other hand, if wires are connected in winter between two poles, then they are kept what? In winter they are kept tight. In summer they are kept loose. Why in summer they are kept loose? So that they may not break when they contract in winter, but they are kept tight when they lay in water winter. Clear? Why? Because they will expand in summer. They will expand in summer and will sag. So just to prevent this they make this arrangement. Now the next one is, in the construction of a bridge, steel girders are used. Clear? And steel girders are placed on rollers. Why they are placed on rollers? The reason is, if there is any rise or fall in temperature of atmosphere, the girder can freely expand or contract without affecting the pillars. Clear? So that is why the girders are placed where? On the rollers. Okay. Now next is the wooden wheels of a bullock cart are fitted with what? Are fitted with iron rims. Why? To ensure a tight fit. The tire is made slightly smaller in diameter than the wheel. Clear? For this, the iron rim is first heated, and due to which what happened? The iron rim expand. The heated rim is then fitted on the wheel. When the rim cools, it contracts and makes a what? Tight fit on the wheel. Clear? That is why the wooden wheels of a bullock cart are fitted with iron rims. Now the next is a cement floor. You must have noticed a cement floor is not laid out in one piece. Why? Because it would crack due to expansion in summer and contraction in winter. So that is why cement floor is not laid out in one piece. But on the other hand, the floor is laid in small pieces. Clear? Small pieces with gaps. You must have noticed in your room, in your classroom, house also, that the floor is laid in small pieces with gaps, and in gaps what is filled there? In gaps glass strips are filled there. Why the glass strips are filled there? Yes, to allow for the expansion during summer. That is why between the two pieces what? Glass strips are filled. Okay. Now the next is the rails. The next is the rails of a railway track are made of steel. While laying the railway track, a small gap is left between two successive lengths of the rail. Yes, a small gap is left between two successive lengths of rails. Why? The question is why. The answer will be what? So that the rails expand in summer, because we know everything, when solid is heated, expand. Clear? So the rails expand in summer. The gap is provided to allow for this expansion. If no gap is left, then what will happen? The expansion in summer will cause the rails to bend sideways, and this may result in what? Train accident. So just to avoid this, a small gap is left between two successive lengths of the rails. Okay. Now the next is a bimetallic strip. Bimetallic strip, which consists of two rods of same length but of different material riveted together, is commonly used in what? Thermostat. What is thermostat then? A thermostat is a device used to control temperature. Clear? What is means which device? If anyone asks this question, that what is the name of the device that is used to control the temperature? So what you will say? Answer will be thermostat. And thermostat is used where? In the electrical gadgets like refrigerator, electric iron, oven, etc. Okay. Now the next topic is thermal expansion in liquid. Like solid, liquids also usually expand on what? Expand on heating. And liquids expand much more than solid Always remember that liquid expand much more than solid. Liquid do not have a definite shape, but they have what? Definite volume. So therefore what? Liquids have only cubical expansion. Cubical expansion means when there is an increase in what? Volume. So exception is here also. Water on heating from 0 degrees Celsius to 4 degrees Celsius contracts. Generally what happens when temperature rises, the things expand. But in case of water from 0 degrees to 4 degrees Celsius, it contracts, and after 4 degrees Celsius what? It expands. And this behavior of water is called as anomalous expansion of water. Anomalous expansion of water. So now I'm going to discuss the thermal expansion of liquid through this activity. So for this, take an empty bottle with a tight fitting cork having a hole drilled in its middle, a drinking straw, 2 bricks, a wire gauze, and a burner. Fill the bottle completely with water. Fill the bottle completely with water. Okay, and add few drops of ink in it. What will happen? It will become colorful. Okay, it will become colorful. Fix the cork in the mouth of the bottle and pass the drinking straw through the cork. You can see in the diagram also. Then put some molten wax around the hole. Why? To avoid the leakage. So this question can come, that why molten wax put around the hole? The answer will be to avoid what? To avoid the leakage of water. Then pour some more water into the drinking straw so that water level in the straw can be seen, and then mark the level in the straw. Then place the bottle on the wire gauze kept over the 2 bricks as it is done here. Clear? You can see. Then heat the bottle by means of a burner and then see the level of the water in the straw. What will you notice? You will notice that water is water. You will notice that water is means you will notice that water is heated more and more, and the level of water in the drinking straw water rises. So this indicates that water expands on heating, and water is water. Water is a liquid. Clear? So through this activity it is clear that liquid expands on heating. Different liquids, again like solid, different liquids expand by different liquids expand by different amounts for the same rise in temperature, and mercury expands more uniformly over a wide range of temperature, and that is why mercury is used as a thermometric liquid. So this is very important question here, that why mercury is used as a thermometric liquid, and the answer will be mercury expands more uniformly over a wide range of temperature. That is why mercury is used as a water. Mercury is used as a thermometric liquid. Now the next I am going to discuss is the thermal expansion of gases. Clear? So like solid, liquid, gases also expand when they are what? When they are heated. Okay, so gases also expand when they are heated, and gases expand much more than liquid and solid. Clear? So now it is very clear that gases expand more than liquid, liquid expands more than solid. Like liquids, gases do not have definite shape, this you know, and so they also have the cubical expansion. Means what? Expansion is related to the volume. Okay. The thermal expansion of air can be demonstrated by the following activity. So let's go through this activity. So now for this, take an empty bottle. Actually the empty bottle contains what? Air. When empty glass you are taking, nothing is there. No, What is there? Yes, air is there. Clear? So empty bottle means air. Empty bottle contains air. Attach a rubber balloon to its neck. Okay, as it is done in the diagram. And initially the balloon is what? Deflated. Of course, place the bottle in water. Place the bottle in what? In a water bath containing boiling water. What will happen? After some time, the balloon gets inflated. Yes, after some time, the balloon gets inflated. What is the reason? That air inside the balloon, what? Inside the bottle expands on heating and it fills the balloon, and so the balloon get inflated. Okay, now take the bottle out of the water bath and allow it to cool by itself. Again, what will you notice? You will notice that the balloon gets what? Deflated and it collapses. This is what is the reason behind it? Because the air inside the balloon and the bottle water has contracted on cooling, and the air from the balloon passes through the bottle, so balloon gets what? Balloon gets deflated. Clear? Now the next I am going to discuss is the three modes of transfer of heat. Clear? So we have read that if two bodies at different temperatures are placed in contact, heat always flows from what? From a higher temperature to a lower temperature. Always remember, when two bodies at different temperatures are placed in contact, then heat always flows from a body with a higher temperature to a body with what? Lower temperature. Okay, now so this flow of heat continues till both the bodies acquire what? Same temperature. Unless until they don't acquire the same temperature, the flow of heat continues. So the flow of heat continues till both the bodies acquire the same temperature. When they acquire the same temperature, then the heat flow stops. We shall study that transfer of heat from a higher temperature to a lower temperature is possible in three different ways. Yes, and these three different ways are called as what? Modes of transfer of heat. And this will be very clear when we will go through this analogy. Yes, this is very interesting also. For this, suppose a teacher wants to distribute apples to each students of the class. Then there are three ways. First is what? That the teacher gives the apple to the first student of a row, who keeps one apple with himself and passes rest of them to the second. Then the second student in the same way keep one apple and passes the rest. Then again third one keep one apple and passes the rest. As you distribute the examinations in examination, when you distribute the answer sheet, you keep one. Clear? And then you pass the rest of the answer sheet to the girl who is sitting back of you. Then again the next one keep one paper with itself, and then the rest of the paper what? The student pass to the back. So this is the first way. Second way, that the teacher can ask each students to come to him one by one along one path, take an apple and return to his seat through another path. Clear? Means coming through one path and going through the another path. Okay. And the third way, that he can throw an apple towards each student and ask him to catch. So these three ways are here. First way is related to the what? First way is related to the conduction. Second way is related to the convection. Clear? Convection. And third way is related to the radiation. So it is very interesting. So now I am going to discuss in detail about the conduction, convection and radiation. Okay. So the first process is what? Conduction. Second one is convection, and the third is radiation. Conduction is analogous to the first method. Yes. Convection is analogous to the second method, and radiation is analogous to the what? To the third method. Okay. So now let's discuss. Yes. So now let's discuss that the modes of transfer of heat is what? Three ways. First is conduction. Second one is convection, and third one is radiation. So conduction occurs in water, solid, gases and liquid, whereas convection occurs in liquid and gases, and radiation no medium required. Clear? Like sun rays comes to the earth through which process? Radiation. Okay. So now next I am going to discuss through an activity the detail of the process. Clear? So for this, take a metal rod and dip it into a beaker containing water which is heated on a hot plate. After some time you will notice that in water some currents are set up and the metal rod gets heated up. In this process, three ways are there. Clear? First, the hot plate is what? First, a hot plate gives off heat into the surrounding air by radiation. Secondly, the heat moves from the bottom to the surface of water in the beaker by what? By the convection. And lastly, the heat moves along the rod by what? Conduction. Clear? So this activity shows all the three modes of transfer of heat. Now I am going to discuss is the conduction. Conduction is the process of what? Transfer of heat from a hot end to the cold end, from particle to particle in the medium. Clear? This is the complete definition of conduction. And so in conduction means what? Medium is required, medium is necessary. Clear? So for this can be understood by this activity. So it is very interesting activity I am going to discuss. Is that for this, take a knife. Clear? Take a knife and put some butter on its entire blade. This you can do at home also. And now hold its tip in the flame as it is shown in the diagram. What you will notice? Butter starts melting and dripping. And first where? First at the tip, and then farther and farther from that end. Clear? The reason is that the heat of the flame, the reason is that what? That the heat of the flame first heats the tip of the blade. The heat is then passed on from particle to particle through the entire length of the blade, which melts the butter along the length of the blade. Okay. One more activity is there. That is also very interesting. So for this, take an aluminium rod. Okay, take an aluminium rod and then hold one end A of the rod in the hand and keep the other end B in the flame. After some time you will notice that the end A of the rod becomes warmer and warmer, and you find it difficult to hold it at the end A. What is the reason? That the reason is that the heat is passed from the hot end B to the cold end A. Clear? Through the particles of the rod. By which method? By the method of conduction. Next is the conductors. Conductors means what? The substances which allow heat. Clear? Conductors means the substances which allow heat to pass through them easily is called conductors of heat. For example, silver, copper, iron, mercury, aluminium, they all are what? Conductors, means they can pass the heat. For example, this activity is very clear. Take an iron rod and a glass rod. Clear? Take an iron rod and glass rod. Hold one end of the both rods in your hand and keep their other ends over the flame of the burner. You will notice that it is easy to hold the glass rod for a much longer time than what? Than the iron rod. Why? Because the iron is what? Better conductor of heat than the glass. Clear? Now, the next is the insulator. Next is the insulator. So insulator means just opposite of the conductors, means which do not allow heat to pass through them are called insulator. For example, wood, plastic, cork, cotton. Clear? So they are what called insulator. The flowing air is a conductor of heat, but still air is what? Insulator. This always keep in the mind, that if air is a conductor of heat, flowing air, and still air means what? Trapped air is a insulator. Okay. Now, so the following activity will show aluminium is what? Good conductor, and what? Aluminium is good conductor, good conductor of heat, while wood is what? Insulator. Okay. So for this, take a hollow aluminium pipe partially fitted on one end wooden cylinder. Wrap a piece of paper on the composite rod at its middle as shown in the figure. So when you will provide the heat, what will happen? You will find that the aluminium conducts heat while the wood water does not conduct heat. Clear? So this is why, this is because aluminium is a good conductor and this wood is what? A bad conductor. Clear? So this much is for this video, and next topic I'll discuss in the next class. Have a nice day.